Today we are going to discuss MCQs from 11 to 20 in our evaluation test which we had in last month. So in last week we discussed the first 10 MCQs and today we are doing the other 10 MCQs. Okay. And we will be discussing the last part of our first structured essay also. Right now let's see what is our first question for today's discussion. Okay, look at the question number 11. So HCl4 is a polar molecule formed by the element X. Its relative atomic mass is less than 50. What is the suitable period number and group number for the element? Right, so when it says HCl4, now just remind what are the possible examples for this HCl4. I just try to remember few. So we can remind CCl4. CCl4, which is the carbon is the central atom. And if it is CCl4, this will be the structure and it is a tetrahedral molecule. Okay. And if you mark the dipole moments, Lamai, all those dipole moments will get cancelled. Okay. All those dipole moments will get cancelled and the resultant dipole moment mu r is equal to 0, which in turn tell us this molecule is a non-polar one. So that means it can't be X can't be carbon. Okay, so then it can't be silicon also. All those options are not going to be there. Okay, and then there is another example. We can take SF4. Okay, so we can't write SCl4. I'll explain later. But let's take SF4. Right, so someone can think for right now SCl4, but I'll explain why SCl4 is not coming. Okay, so focus on this one. Let's say it is SF4. Okay, then the molecule is going to be like this. There will be a lone pair and like this. Okay, so this is it is having seesaw shape, and you can see if you mark the dipole moments, this molecule is going to be polar. This is correct. And there is another example for HCl4. You can take HCF2, HCF4. Okay, HCF4 will be like this, and you can see square planar shape. Square planar shape. And that is also non-polar because you can see all the dipole moments are getting cancelled. So here also mu r equals 0. That means it is non-polar. Okay, so the possible one is going to be sulfur. Possible one is going to be sulfur. Okay, that means it should be in group 16. So sulfur is there in group 16. It is sulfur. So sulfur is there in group 16. And the period of the sulfur is in the third period. So if you take the group 16 elements, oxygen, sulfur, selenium, tellurium, there are several elements. Okay, you can't take oxygen because it can't make OF4, right? OF4 doesn't exist, cannot violate octet. Okay, because it cannot violate octet. OF4 is not going to be an answer, right? And let's write the relative atomic masses too. Okay, relative atomic mass of this one is 16, this one is 32. Selenium, we can go to a periodic table. I'm having a periodic table right now, which is there in our paper. Selenium atomic number is 34. Okay, so that means its relative atomic mass should be at least greater than 2 times of the 34. Okay, so that means selenium is also not going to be the answer, selenium and tellurium, because of this condition. Understand? Because their relative atomic masses are higher than 50. Okay, so then the possible and correct option is going to be sulfur. Understood that one, Lama? You just have to use your practice for this question. Okay, just remind what are the possible molecules that can form bonds with 4 halogens. Okay, CCl4, SF4 and HCF4. So in 12th question, It's a chemical calculation. We'll see how to do it, and I'm going to explain that one a little bit more to make sure you get that practice, okay? So they have given us a reaction between barium hydroxide and carbon dioxide. Then look at the information they have given. At 27 Celsius, pressure of a carbon dioxide sample kept in 16.628 closed rigid container. And it says the pressure as 1.2 into 10 to the power 5 Pascal. It says we pass this carbon dioxide through 250 cubic centimeters of barium hydroxide solution. Do they have given us the concentration of that one? Yes, it is given. So 2 moles per decimeter cube. Okay, from that we can find barium hydroxide moles. So it's asking what is the limiting reactant and final concentration. It's asking the barium bicarbonate. That's the name we give for this compound. Barium bicarbonate concentration. Okay, so let's see how to do that question. Now listen carefully. It's not a difficult one, but still it will remind you all the theories about this particular question. Okay, so we have a name for this type of a question. Okay, we have a name for that one. Remember, the typical questions we discussed under chemical calculations falls into several categories. Okay, so we have stoichiometry bridge questions. And then this one, we gave a name for that, ARR, added, reacted, remaining type questions. Okay, so you can see here, there are two reactants and both reactants, they have given data. So using this data, you can find out moles of both reactants. So you can find out moles of barium hydroxide here. Okay, and then you can find that given data for the carbon dioxide, you can find the moles of carbon dioxide also. So when you are given data regarding two reactants, you need to decide which one is going to completely react. Okay, you just can't look at and say, okay, first you have to balance the reaction, then you have to apply that mole data, and you have to compare that ratio and decide which one is going to completely react. Okay, so let's do the first and most important thing, which is the balancing the reaction. Okay, for this balancing, right now we are using inspection method. Okay, so check this two sides and you can see two carbon atoms here. That means you need to put 2 in front of this carbon dioxide. So then check oxygen atoms get balanced. So the ratio is going to be 1:2, is to 1. This is the ratio. That means 1 with 1 barium hydroxide, okay, 2 carbon dioxide is going to react. Okay, that's a simple idea. So now let's find out number of moles. Okay, so how do we find the moles of barium hydroxide? So look at the data they have given. We know the volume and we know the concentration. So we can find the moles using N equals CV formula. Okay, concentration into volume. So 2 mole per decimeter cube. Volume is 250 centimeter cube. That means if you put it into decimeter cube, 0.25 decimeter cube. Okay, so it's equal to 1/4. So it's going to be 0.5 moles. Okay, Lamai. So barium hydroxide moles are going to be 0.5. Then let's find the carbon dioxide moles. Okay, for carbon dioxide moles, they have given these data: volume, temperature, and pressure. So do you remember what is the formula we have to use for that? We have to use formula that we learn in gaseous lesson, which is our next month lesson. But anyway, we know that formula already. We call it as PV equal nRT. When we know the pressure, volume, and temperature, we can find the number of moles using that PV equal nRT formula. Okay, right. But there is an important thing regarding that equation. When we use this one, we must substitute these values in SI units. Okay, we must use SI unit. That means we can't use this decimeter value. Instead of that, we have to convert it into cubic meters. So into 10 to the power minus 3. Divide this by 1000. Then you can convert it into meter cube. Okay, just remind those things. Okay, and temperature, we have to convert that into Kelvin. So add 273. It's going to be 300 Kelvin. And pressure you can use in Pascal. Okay, now if you apply that data, 1.2 into 10 to the power 5 Pascal, or you can say Newton per square meter, into volume 16.628 into 10 to the power minus 3 meter cube, and then divide this one by R value 8.314 joule per mole per Kelvin, and divide by temperature 300 Kelvin. Okay, so what's going to be the answer? Okay, you can see these things are divisible. Here 1, here 2, right? And this one can be divided 0.4. 0.4 into 2, 0.8. Yeah, so it's going to be 0.8 moles. 0.8 moles. Yeah. Okay, so those are the number of moles of both reactants, barium hydroxide and carbon dioxide. So just see whether you understand that part. So what are the two things we did? We balanced the reaction, then we found the number of moles. Okay, so I'll explain you after that, but just try to understand these two things we did. Right, so you are using ARR method, added, reacted, and remaining method. Okay, so let's write down how many moles are added from these reactants. From barium hydroxide, we have added 0.5 moles, and from this one, we have added 0.8 moles. So then who's going to be the limiting reactant? Let's try to understand this. With barium hydroxide and carbon dioxide. So if one is added, 2 of this is needed. Let's say you add 0.5. Then how much of carbon dioxide is needed? You need 2 times like that, no? So that means 1.0 of carbon dioxide is needed. But do we have that much amount? We need 1.0 of carbon dioxide. But we only have 0.8, right? So carbon dioxide is not going to be enough. You get the idea? Carbon dioxide is not going to be enough. So this ratio is not going to work. Okay, so now let's go with that one for carbon dioxide. We have 0.8 now. We need half of this one, half of this amount. That means we need only 0.4. So that amount is there from barium hydroxide. Okay, so then you can understand CO2 is the limiting reactant. CO2 is the limiting reactant, and barium hydroxide will be the excess reactant. Okay, so this whole 0.8 will react, and with this 0.4 will react, and here 0.4 will be formed. Number of moles, because if one reacted, one will be formed, and the remaining one will be 0.1 of barium hydroxide, and nothing will be remaining from here, and 0.4 moles of barium bicarbonate is formed. Okay, so the first question they ask is, what is the limiting reactant? So now we know the limiting reactant. What it is? It is our carbon dioxide. Okay, so now let's see the second part. They ask for the concentration of barium bicarbonate. Okay, to find the concentration, we need the number of moles. So we know the number of moles. What is the number of moles? 0.4. Okay, so barium bicarbonate concentration. So divide this 0.4 by total volume. Total volume is 0.25 decimeter cube. Okay, 0.25 decimeter cube. Right, so it's going to be, this is 1 over 4, so 4 was above 1.6 moles per decimeter cube. Okay, so this is going to be the answer. Is that clear, Lam? So now we finish the question. Let's check our answer. The limiting reactant is carbon dioxide, then concentration of barium bicarbonate is 1.6. Answer is answer 4. So we did the 12th one. The 13th one from bonding lesson again. It's asking the most acceptable Lewis structure for thiocyanate. So let's see how to get that structure according to our Lewis method. So this will be the skeleton. find out the total number of valence electrons. Okay, from one nitrogen, you have 3 valence electrons. So 1 into 5, 15 valence electrons from one nitrogen. So from 3 nitrogen. So 3 into 5, 15. And with that negative charge, it means extra electrons. So add them, you'll get 16 valence electrons. From those 16 valence electrons, you already have represented 2 and another 2. So 4 of them are represented. So subtract them. You get 12 electrons. So 12 electrons means 6 electron pairs. So those electron pairs you have to apply to the molecule, apply to this skeleton until their octets are completed. So if you apply them to the peripheral atom, peripheral to nitrogen, then it will be finished. Okay. So then think about a way to complete the octet of the central nitrogen. So there are 2 ways to complete the octet. Let's see how those 2 ways are going to be. You can select one lone pair from each nitrogen. Then you can get this structure. You can get this structure. Okay. Or you can take both lone pair from only one nitrogen. Then you will get this one. Okay. So then the final step is applying the charges. Here you will have a minus charge, and a plus charge. Overall charge is going to be -1. Here you will be having a plus charge and -2 charge. Okay, so these 2 are the structures. Actually, these 2 are resonance structures of each other. There will be another resonance structure for this one. Like this. Which is kind of a mirror of that other second one, sorry. And they are asking the most stable structure. Okay, but actually both structures are having their own good characteristics. Okay, so if you take the first one here, it is symmetrically charge distributed. Okay, but there are 2 charge places. But if you take the second one, you have only in the first one you have negative charges in 2 places. But in the second one, you have negative charge in only 1 place. So like that, both molecules are having their own good characteristics. So I gave marks for the both third and fourth answers. Okay, so you can take both as our answers, right? So, but other structures, so the first one octet is not completed. Okay, the second one is also having incomplete octets. So they are anyway wrong. If you take the fifth one, there also octet is violated. So it can't also happen. So the possible 2 answers are answer 3 and answer 4. Okay, so what you have to practice here is the Lewis method. 14, 15 questions are from, again, chemical calculations. Okay, let's do the 14th one first. In 14th one, so they are asking the concentration of the resulting solution. So the resulting solution will contain 200 cubic centimeters. This is your final volume. Still the same moles of ammonia is there. So they are asking the concentration. So let's call it as C2. So this is your B2, this is your C1, and this is your B1. And since it is a dilution, we call this theory as dilution. Adding water is dilution. For dilution questions, we use this formula C1V1 equal C2V2. Okay, why? During dilution, number of moles are constant. Understood, Lama? That is the reason behind this. Okay, so let's say the moles of this solution is going to be C1V1. That same moles will be there in this solution, because during dilution, moles is constant, only volume is increased. Okay, so same moles are there now in a larger volume. Okay, so since these 2 are equal, you can just say C1V1 equal C2V2. Okay. Now let's apply and see the answer. They're asking for the C2, 0.2 into 50 divided by 200. Okay, no need to convert the unit because centimeter cube get cancelled. Okay, so 0 point, it's going to be 4, no? 0.05. This is the new concentration. So concentration decreases by 4 times. Decreases by 4 times. Answer is going to be answer 2. Understood, Laman? So read the question carefully. Final volume is not 150, okay? They says 150 water is added. So that means you need to add that 50 and 150 together to find the final volume. Okay, because of that point, this question is a good one. So it says H3PO4, 30 cubic centimeters of H3PO4 is titrated with KOH solution. KOH solution, its concentration is 0.2. And it says the volume KOH required is 18 cubic centimeters. That endpoint means where the color change occurred. I'll explain that one in a minute, okay? So our target is to find the concentration of this H3PO4. Right. Okay, now let's see. Let's say you are adding phenolphthalein into this solution. Phenolphthalein. So this is acidic medium. So phenolphthalein in acidic medium, it is colorless. Okay, so when the reaction completed, that means when it reacts with KOH fully, so it changes the color into basic medium color, which is pink. You will discuss more about these indicators in a later lesson. Right now, just understand endpoint means where the color change occur. Okay, so color change occur after adding 18 cubic centimeters of potassium hydroxide. Okay, so that means we understand we require 18 cubic centimeters to fully react with this 30 cubic centimeters of H3PO4. Okay, so they're asking the concentration of this solution. Okay, now let's see how to get that answer. Right, so first of all, we need the reaction between these two chemicals. Okay, so earlier when they give a reaction, they usually give the products. Okay, but for this particular reaction, here you can see in the question, they haven't given us the products. Why? Because this is an acid-base reaction. Okay, during acid-base reactions, we know what are the products, right? So acid and a base react to form what? Reacts to form salt and water. Remember, salt and water. So this acid H3PO4 will react with KOH. To form salt and water. So what is this salt? Let's try to understand the formula of that. So this H3PO4 you can break this one into anion and cation. PO4 3 minus is the anion and you have 3 H pluses. And here you have K plus and OH minus. So this H plus and OH minus is joining to form water, one water molecule, okay? So then what happens to these potassium and phosphate ions? They will join to form the salt. So now let's try to get the formula of this salt using our O-level knowledge. So we can change the valencies. 3 and 1, cross this one, and you get K3PO4. You need 3 potassium ions. Or simply understand, to counter this -3 charge, you need 3 positive charges that comes from K3. Okay, so however, this is the formula of this salt. Right, so to do that, we need 3 KOHs So that means 3 OH minuses. That means 1 OH minus joined with 1 H plus to give 1 water. So 3 of each will join to form 3 water molecules. So this is the reaction. And right now we have our ratio. This ratio is the one we needed for the question. Right, now let's see how to do the rest. We can find the moles of potassium hydroxide. You have 0.2 moles, mole per decimeter cube, into 18 cubic centimeters. 18 into 10 to the power minus 3 decimeter cube. So if you simplify this one, okay, it will be 3.6 into 10 to the power minus 3 moles. Right, so now we know the ratio between potassium hydroxide and H3PO4 is 3:1. Therefore, we can find moles of H3PO4. Moles of H3PO4 will be 1/3 of this amount. So 3.6 into 10 to the power minus 3 divided by 3. 1.2 into 10 to the power minus 3 moles. This is the moles of phosphoric acid. Okay, so they are asking the concentration of this acid. So let's divide this number of moles by the volume of the solution. Volume is 30 cubic centimeters. 30 into 10 to the power minus 3 decimeter cube. Okay, so 0.12, 0.04 moles per decimeter cube. Okay, so if you divide this one by 3, 0.4 is there. If you divide it by again from 10, 0.04 will be there. Is that clear, Lame? Answer is answer 1. Right, now let's go to the next question. The correct answer for the chemical species, there are 5 chemical species arranged in the increasing order of the electronegativity of carbon. Yeah, electronegativity is a unit 1 theory. Ability to attract electrons of a bond toward itself. That is the definition of electronegativity. Okay, but in unit 1 we gave fixed values for that. For example, carbon, according to Pauling scale, electronegativity value is 2.5. But in the second lesson, we explained again electronegativity for elements of for atoms of same element, here like carbon, is going to change depending on their nature. That means depending on how many bonds it has made, depending on the hybridization of the atom, depending on the charge, like that several factors affect the electronegativity of an atom in a compound. Okay, so even though we say 2.5 for carbon in Pauling scale, that 2.5 is not going to stay as a constant value. It might change a little bit. Okay, for the 4 carbon atoms we see in these, 5 carbon atoms we see in these molecules are going to have different electronegativities. That's the basic idea. Then we learned a method to compare those electronegativities in unit 2. Okay, so we have a small mnemonic for that method. What is the mnemonic? We call it as scope. Right, so let's use that principle and do the question. So I wrote the 5 molecules here and let's try to arrange them in ascending order. Okay, so first thing, we need their molecules. We need their structures. So this is the structure for the CCl4. This is the structure for the CF4. I am ignoring their lone pairs. This is for CH4 and CH2F2. And finally, COCl2. These are the structures. Okay, so in scope, this is our method of comparing electronegativity. What is this S? S stands for the S percentage. Right? S percentage. So what are the S percentages of these molecules? So this is how you take that. So here you can see this central atom. Around this central atom, electron pair geometry is tetrahedral. If it is tetrahedral, hybridization is going to be sp3. For sp3 hybridization, S percentage is 25%. That means one of the 4 orbitals participating for the hybridization is sp3, 1s and 3p. That's the idea. So that means 1/4 is S. So S percentage is going to be what? 25%. Okay. So for any tetrahedral molecule, here S percentage is going to be the same. For the first 4 molecules, S percentages are 25%. What about the last one? Here the hybridization is sp2. That means only one orbital from 3 orbitals came for the hybridization is S. That means 1/3. 1/3 is 33.3%. That is the S percentage of this carbon. So you can see S percentage is higher for this molecule. That means this carbon is the most electronegative carbon. Okay, so all the answers, the correct answer should end with this one. So there are only 3 answers that are ending with COCl2. You can cut the other 2 answers. Okay, like that, eliminate. So S percentage is the first point. Then C stands for charge. Charge, you have to look for the charge on carbon. Charge on that atom considered, okay, not the overall charge. So here, all these atoms are having no charge. So I'm not going to compare this one anymore because you already know it is the most electronegative. Right, and the next thing, oxidation number. Oxidation number. Right, so chlorine is more electronegative than carbon. So it partially loses 4 electrons. Oxidation number +4. Same thing applied for CF4. Oxidation number +4. What about this? It gains electrons, right? It gains 4 electrons partially. So oxidation number is -4. Here, it gains 2 electrons and it loses 2 electrons. Gain 2, loses 2. No gaining or no losing. Oxidation number 0. Okay. So then, if oxidation number is higher, let's say these factors are high, your electronegativity is going to be higher. Okay, so then this one is having the lowest value. Okay, so this is going to be the least electronegative. Then this one. So we know about the least one, CH4. Then CH2F2. Then we don't know the other two. It can be CF4 or CCl4. But highest electronegativity is COCl2. Then if you check the answers, okay, the remaining 3 answers, 2 of them are starting with CH4. You can cut the answer 1 also. Right now, to decide the electronegativity higher one, you have to go for the last point. PE. What is PE? Peripheral atom electronegativity. If the peripheral atom is more electronegative, central atom is also going to be more electronegative. That is the logic. Okay. So here, electronegativity of our fluorine is higher than chlorine. That means this is going to be the having a higher electronegativity. Okay, so that means CF4 is more electronegative than CCl4. So you can find this answer in answer number 5. Yeah, then let's go to the 17th one. So they're asking the bond angles of these 4 molecules. We need their Lewis structures. Okay, so now let's first get their Lewis structures. Central atoms of all these molecules are going to be iodine because it is the least electronegative one when you compare chlorine and iodine. So iodine is the central atom. Here you have 2 chlorine atoms around that. And there must be a negative charge also. So usually iodine is having 7 valence electrons. Like this, it will have 3 lone pairs with the negative charge on central line. So it's going to be linear shape, which is coming from trigonal bipyramidal electron pair geometry. Understood, Lama? That's how we take, okay? I'll explain a little bit more about the structure. If it is ICl2 minus, think about the valence electrons of chlorine. Iodine, sorry. There are 7 electrons. So only 2 are going to make bonds with chlorine. And there will be 1 electron coming from the negative charge. So the result is 6 electrons. If you put it into lone pairs, that means 3 lone pairs. Like that, think. If you apply the same principle for ICl3, it's going to be like this. Okay, 1, 2, 3, 4, 5, 6, 7. So this is T shape. And then ICl3 2 plus. Then it's having 7 electrons. So 3 gone for chlorine. And another 2 is reduced for the plus 2 charge. Okay. So then 5 is gone, only 2 electrons. That means 1 lone pair. 1 lone pair. So around this iodine, you have 3 chlorines and 1 lone pair. And 2 plus charges. So it's going to be pyramidal. Trigonal pyramidal. And the final one, ICl4 3 plus. ICl4 3 plus. So 7 minus 4 minus 3. 0. So no lone pairs. It's a tetrahedral molecule. It's a tetrahedral molecule with 3 positive charge at center. Like that, just get their structures. These are not the Lewis structures, Lamai, because I didn't add the lone pairs to chlorine. But anyway, this is enough for our comparison. Yes, what are the angles? If it is linear, then if you check the angle between these two, it's going to be 180 degrees. Now here, we are checking the angles here. It's not exactly 90, but it is going to be somewhere around 90. Okay. And this is a tetrahedral one, exactly tetrahedral. So ideal bond angle 109.5 will come. But here, bond angle will be a little bit low because of the repulsion from the lone pair. So it's going to be 107 degrees. Remember, we subtract 2.5 degrees for one lone pair. Okay, so these are the bond angles. So if you arrange them in ascending order, starting from, let us start from ICl3. Then this one, ICl3 2 plus. Then you have ICl4 3 minus, sorry, 3 plus. Then the largest bond angle is ICl2 minus. Shall we go to the next one? Question number 18. Which of the following molecule is easiest to vaporize under atmospheric pressure? Easiest to vaporize. It's a good question, huh? Easiest to vaporize. We'll talk a little bit about that. What is this vaporization? What is meant by easiest to vaporize? So vaporization depends on these intermolecular attractions. Okay. So let's say if your intermolecular attraction is weak, then what will happen? This molecule is very likely to vaporize. It can become free from that other attractions easily. When you heat a little bit, it will go to a vapor, go to the vapor phase. That's what happens. Understand? So if your intermolecular attractions are weaker, then we say volatility, or ability to vaporize increases. Okay, in other words, we can say boiling point decreases. It is becoming easy to boil. That means at lower temperature, it will boil. Okay, later we will discuss what is boiling point and make more things about that. But just know, boiling point, volatility, they all depends on the intermolecular attractions. If intermolecular attractions are weaker, it is easier to vaporize. It is having lower boiling point. Try to understand that. Okay, don't memorize. Okay, understand. Then when they ask which one is easiest to vaporize, you have to think about their intermolecular attractions. So look at the question. Okay, so you have to check the molecule with weakest intermolecular attraction. So now I'll list the molecules. We have NH3, then we have SO2, CH, Cl3, CO2, and NO2. So now let's discuss their intermolecular attractions. Intermolecular attractions, okay? So NH3 is having hydrogen bonds. It can form hydrogen bonds and London forces. And SO2 is a polar molecule, so it will form dipole-dipole interactions. Okay, so CH3Cl also we can say polar or non-polar, but anyway, mainly it will form London forces. Mainly London forces. It can form DP-DP also, right? And CO2, you have London forces only. London forces only because it is a non-polar molecule. NO2 is a polar molecule, so it will have DP-DP and London. Here also, basically any molecule can form London forces, but for non-polar molecules, you have only London forces. You have only London forces. Understood? So London forces are the weakest, no? Weakest, no? Right? And their relative molecular masses are also at the same range. Okay, so CO2 is going to be the one with the weakest intermolecular attractions. Easiest to vaporize. Easily vaporized. Okay, so we can take these three relatively equal relative molecular masses. Okay, so if they are having relatively equal relative molecular masses, then the one with the polar molecules will be having higher boiling points. Okay, and here CHCl3, you have 3 chlorine atoms. It's a very heavy one molecule. Therefore, it will have more London forces. And here you have hydrogen bonds. Like that, you can eliminate all other answers and you can select our answer. Answer is answer 4, carbon dioxide. Okay, so that is the answer for the 18th MCQ. It's from bonding. Secondary interactions. Remember that one, huh? Volatility. And CO2 is the one with the lowest boiling point. Okay, lowest boiling point. Right. Shall we go to the question number 19? It is asking which of the following statements regarding a chemical bond is incorrect. Which of the following regarding a chemical bond is incorrect? Look at the answers. When a dative bond is formed between two atoms, an orbital containing a lone pair in one atom linearly overlaps with an empty orbital in the other atom. Yeah, so it's not wrong actually. What is happening in a dative bond is there is a donor with 2 electrons. We say it has a lone pair, and there is an empty orbital. We call it as an acceptor. Donor and acceptor is there. Donor and acceptor is there. This is what is meant by the dative bond. So this electron is transferred to this other empty orbital, and will have a situation like this, and they become overlapped and form the bond. And usually, not usually, it's always it is making linear overlapping. Okay, linear overlapping means they overlap along their internuclear axes. Okay, just don't mind about the linear thing. Just understand this is what happens during the dative bond formation, right? You have a donor and then you have acceptor. Have an acceptor. So first one is okay. Then let's try the second one. The molecule N2, there are 2 sigma bonds and 1 pi bond. In N2, It says there are 2 sigma bonds and 1 pi bonds. What do you think? Is that clear? Is that correct? Sorry, is that correct? No. You have 2 pi bonds and you have only 1 sigma bond. Okay, so remember this point. Between any two atoms, between any two atoms, there is only one sigma bond, because there is only one linear overlapping. There's only one internuclear axis between any two atoms. Therefore, only one bond can form along that internuclear axis. Okay, so between these two nitrogen nuclei, only one axis is there. Along that, only one bond can form. Okay, so no multiple bonds are formed, right? So if it need to make multiple bonds, it has to undergo lateral overlap using p orbitals. They can overlap laterally. Okay, so only one sigma bond. Remember that. So this is wrong. This is the answer. Let's see the other statements. They must be correct. We'll quickly review them. Write something in front of that. Okay, so if you take carbon dioxide, yes, it is. Its 2 pi bonds are perpendicular to each other. Okay, which is we already know that point, because this carbon is sp hybridized. That means there are 2 p orbitals that are unhybridized. This is one p orbital along your y-axis, and there is another p orbital. I'll draw it in the black color. There's another p orbital in other axis, is it? Okay, and with this there are 2 sp orbitals also. So one orbital is making a bond with one oxygen atom. These are the linear overlappings, and one oxygen atom p orbitals are overlapping laterally like this. This pi bond is perpendicular to the bond, and the other one, the blue color one, is along the bond. Okay, so the 2 pi bonds will be this blue color one along the bond and the black color one perpendicular to the bond. So that means 2 pi bonds are perpendicular because the 2 p orbitals of the central carbon are perpendicular. That is the reason. So it's a good point. Huh? It's a good point. Look at the 4th and 5th points. 4th point is energy of a sigma bond is greater than energy of the pi bond. True. You can write the reason in front of that. What is the reason? Because in linear overlappings, internuclear bond occur along the internuclear axis. Linear bond occur along the internuclear axis. Therefore, it is strong. If the bond occur along the internuclear axis, it is going to be strong. Remember that, huh? It is going to be strong. Is that also true? Look at the last point. It must be also true. S orbitals cannot laterally overlap to make pi bonds. True. Because S orbitals, there is no lateral side. Only p orbitals undergo lateral overlapping. Okay, only p orbitals and d orbitals in some cases undergo lateral overlappings, not others. S orbital always make SS linear overlapping, not lateral. Okay, p orbitals can overlap laterally and linearly. This is lateral overlapping, and p orbitals can overlap linearly. So it's a good question about overlappings, no? It's a good one. Study. You will find related information regarding these overlappings and these things about in the topic hybridization. Go through those pages. Right, go to the next one, 20th one. It is asking the correct statement regarding the structure of the following compound. I'll draw the structure they have given. Triple bond C, COH. And they have labeled the atoms also X, Y, Z. All the carbon atoms, okay? Right. So these carbon atoms labeled as X, Y, Z lie on the same straight line. Is it true? Is it true? It is obviously going to be true, no? So because this is sp hybridized or linear shape, angle is going to be 180. So all these 4 atoms, not only 3 carbon, that hydrogen also, lie in the same straight line. Same straight line. Okay, so they are linear. Same straight line. And that means the first statement, A, is correct. What about the next one, B? All atoms of the above molecule lie in one plane. All atoms. If they mention all atoms, they talk about this carbon and so this hydrogen and oxygen also. Okay, so if they are in the same plane, we know they must be sp or sp hybridized. Okay, so we can say all central atoms are sp or sp2 hybridized. So therefore, they all lie in the same plane. Isn't it? Same plane. That is also correct. Because here you can say bond angle is 120. 120, so everything is there in this board. You can properly show the angles. If you know the actual angles, you can show the angles. So that means these 3 carbon atoms along with this hydrogen, they are in the straight line. And all these atoms, because the central atoms are either sp or sp2 hybridized, no? Then they are going to be in the same plane also. Okay, same plane also. Right. So 2 statements are correct. Now let's check the other 2. Electronegativity of the labeled carbon atoms increases. So here, Z atom, this carbon is sp2 hybridized. Okay, and these carbon atoms are sp and sp hybridized. So then they obviously have higher S percentage. That's true. But if you have the same same S percentages, then you check for the charges. Here we don't have any charge. But if you check for the oxidation numbers, here the oxidation number is -1. Here the oxidation number is 0. If it is having -1 oxidation state, it is less electronegative. Less electronegative. Electronegativity is low. Related to that, 0 is a higher value now. This is more electronegative. Okay, so it's not X. This order is wrong. These 2 places should be exchanged. So the proper order is it X and then Y. Okay, so your C statement is wrong. Is that clear, Lama? It's about electronegativity. We learned this scope thing in an earlier good question also. Right? And then check the last one. The bond angle around the carbon atom labeled as XY are 180 angles, 180 degrees, and around the carbon atom labeled as Z is exactly 120. Yeah. X and Y, you can say 180. But can we say this bond angle is exactly 120? Exactly. That word has a little bit of a weight, no? Some meaning is there. Can we see this, say this angle around Z is exactly 120? No. It's approximately 120, but we can't say for sure because this is a double bond. Double bond. Double bond has more repulsion. More repulsion on other bonds. Other bond pairs, it exert more repulsion. So therefore, bond angle in this way it increases and this way it should decrease. Let's say this must be maybe 118. and this will be a little bit higher than 120. 121 can be happy. Approximately, we can say it is 120, but when they say exactly 120, that is statement is wrong. Okay, Lama? So 20th one, D statement also wrong. So answer is going to be answer 1. They are asking the correct options. Now let's go to our discussion on our structured essay question. We did a part of that structured essay question. No, I think we did the first part and we saw how to get the Lewis structure. And this, up to Lewis structure we did. Right, so it's asking for you to draw the third one. They're asking you for you to draw the resonance structures. It's asking for you to draw 3 more resonance structures. And these are the answers. I think you have the paper with you now. So draw these structures there. Just draw the structures, the number of structures. You can draw, including the given one, you can draw 7 structures. Okay, 7 structures. Now let's try this table thing. I'll get this structure for our discussion, but the table is really simple. Now, if you have any mistakes, try to correct that one by looking at the answer. So around this, N2. Around this N2, you can see 3 repulsion units, a lone pair, a double bond, and a single bond. We consider the double bond to be 1 repulsion unit. Okay, so we have altogether 3 repulsion units, 3 VSCPR units. So then the electron pair geometry is going to be trigonal plane. You write it trigonal plane. And the shape is going to be angular because you have 1 lone pair. And hybridization is sp2. One of the p orbital is saved to make the 5 bond with this C1 carbon. Then they're asking about O3. You can see there are 2 lone pairs and 2 bond pairs. So 4 repulsion units. Okay. And tetrahedral shape is going to be angular. It's actually, they are like water molecule. Okay. The 2 lone pairs will be at the same side, not like this. And hybridization is sp3 since it is tetrahedral. And about this sulfur, next one is about this sulfur. You have again 4 repulsion units. So it is again tetrahedral, but there is only 1 lone pair. So it's pyramidal. And hybridization is sp3. And the last one, C5 carbon. You have 2 lone pairs only. So 2 repulsion units only, 1 triple bond and a single bond. So linear, and sp. Write this in your table. Okay, I hope you don't have any doubt there. And the next part is also interesting. They're asking you for the orbitals which made these bonds. These are the answers provided. Br and C1. So bromine here, we can say bromine either hybridized or unhybridized, right? Remember, if it is hybridized, we can say sp3. And this carbon sp2. If it is considered unhybridized, you can say it is 4p and sp2, not 2p or 3p. Okay, it is 4p because bromine is in the 4th period. Go to the period table and see. Bromine is there in the 4th period, just under the chlorine. Chlorine is in the 3rd period now. So bromine will be there in the 4th period. And then the next bond is C1 and H. This. So C1 is sp2. And this hydrogen you have to say 1s. 1s always, okay? 1s. Because it's having only 1 orbital, s orbital, a smaller one. And C1 and N2. Here there are 2 bonds. Let's say this one is a sigma bond and the other one is a phi bond. Sigma bond and phi bond. So sigma bond is made between sp2 overlapping. And this phi bond is formed between 2p and 2p lateral overlap. 2p and 2p lateral overlap. Understood, Lamai? And then asking N2N, N2NO3. N2NO3. Here sp2, sp3. Then you have O3 and S4. sp3, sp3. S4 is sp3. Okay. Then the sixth one, sp3, sp. Like that. So we said this atom is sp3, no? sp3, no? So then how this 5 bond is formed? Is there any explanation for that? One of these bond is a 5 bond. No? How this 5 bond is formed? Formed using 3d orbitals. Remember that discussion we did earlier? In earlier papers, you can find this. Where we discussed 2018 A-level essay, go and check that. I explained extensively about that. Okay, so the other 5 bond, the 5 bond that is there is formed by d orbital. Remember that. It is not asking the paper anyway, but you can remember. Okay, so these 5 bonds are made by 2p. Don't just blindly write 2p 2p whenever they ask 5 bonds. Okay, just think and write. Okay, because if they are second period elements, that's why 2p is coming. If suddenly if this was silicon or something, then it is 3p. Okay, in the case of sulfur here it is 3d, but that is not in the syllabus. That's why they are not asking in the papers. But however, in the 2018 A-level paper, I explained that point. Bond angle thing. So here C1 is tetrahedral as a trigonal planar, and there are no lone pairs. So that's why 120 bond angle is written. For N2, it is also trigonal planar, but there is a lone pair. So lone pair pushes a little bit. So you have to subtract 2.5 degrees. Okay, so I took here 117.5. But in the A-level exam, you will be given marks for 118, 119, 117, like that. You will get answer marks because the answer is actually added as a range. Okay, so don't worry about that. But anyway, don't write 120, okay? And angle should be lesser than that. Then for oxygen, there are 2 lone pairs now. So subtract 2 times 2.5. That means 5 degrees from tetrahedral bond angle 109.5. If you subtract 5 from 109.5, it is going to be 104.5. Here also you will be getting marks for 105, 104, like that. Then S4, a tetrahedral, 1 lone pair is there. So subtract 2.5 degrees from 109.5. It's going to give you 107 degrees. And the last one, linear, 180. And again, they are asking that 5 bond orientation. If there are 2 5 bonds, then they are perpendicular to each other. Okay, perpendicular. Only very few of you wrote that point. Because earlier we discussed these things in our paper classes. Most of you are not going through that. So study properly. Use the paper discussions we did earlier. There is a lot to learn. Now let's come to this last ascending order discussions. First thing is asking about their radii. Ionic and atomic. Ions and atoms both are there. So let's discuss about their radii variation. First thing is about F minus, sodium plus, and lithium. Right, so F minus and sodium plus are isoelectronic. Isoelectric. So if you take F minus and sodium plus, number of protons are 9 and 11. But number of electrons you have 10 and 10. That's why I said isoelectric. So however, since sodium plus is having more protons, then it is having more nuclear attraction. So then sodium plus is going to be smaller than F minus. Then the question comes with lithium. It's not lithium plus, okay, it is lithium metal. Okay, lithium metal. So lithium is a group 1 element, so period 1 element, so period 2 elements and group 1. And it's kind of the largest in the period, okay? So in your period, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, and neon are there. So this becomes a little bit larger because of it becoming F minus. So F minus will be little larger. Let's say this is like this. F minus will be somewhat like this. But lithium plus, it's a group 1 element, no? It is very large. Okay, so then the largest one is going to be lithium. Is that clear? So you may have a doubt there, but just know if it is not an ion, it's a nice to know point, okay? Just remember lithium is large, okay, in this question. Study this, then it will be okay. Right, and we discussed today bond angle, electronegativity, everything. Right now here, this question is about bond length, second one. It's asking the bond lengths of NO2 minus, NO2 plus, NO3 minus, and NH4 OH bond angles, increasing order of the bond angle. We'll see. Right, so we need the Lewis structures of them. NO2 minus, this is the Lewis structure. And NO2 plus, this is the Lewis structure. NO3 minus. And NH4OH, I gave you the skeleton during the exam. This is the NH4OH. So it should be actually NH2OH, no? Yeah, NH2OH. Okay. So now here you have a single bond. NO single bond. It's actually single bond. Here you have NO double bond. NO double bond. So double bonds are shorter than single bonds. Double bonds are shorter than single bonds. Right? And then you have a problem with the NO2 minus and NO3 minus. Now I'll explain it regarding NO2 minus. You can understand it for NO3 minus. So this is the resonance structure of this molecule. And actual structure is a hybrid of that one. That means in the actual structure, bond length between single and double in between nature. Remember, we can put bond order 1.5 for this one. Okay. But if you apply the same thing for this one, bond order of NO3 minus is going to be, remember, 1.33 because this 5 bond is divided among 3 places. So 0.33. So that means this is having more single bond character. More single bond character than NO2 minus. Okay, so therefore you can say NH2OH is the largest bond length. They're asking the ascending order now. So NO2 plus is the smallest one, then NO2 minus, then NO3 minus, and the largest bond angle is NH2OH. Going to be the answer. And then the next one, most of you got wrong about the boiling points of HCl, HBr, those things. It is, you learn that one under the secondary interactions. Just remember this order. HF, HCl, HBr, HI. Okay, so this is having unexpectedly higher boiling points due to hydrogen bonds. These are not forming hydrogen bonds. Since their relative molecular mass increases, their London forces are increased. That's why gradually it increases. So If they ask the ascending order, the lowest value is HCl. Only few of you got this correct. Then it is HBr. Then it is HI. The highest boiling point will be therefore HF. HF. Okay, highest boiling point is therefore HF. That is the answer for the third one. Third one. Just remember that one, okay? And study that well. And if it is asked for ammonia and others, water also the same thing goes. H2S, H2SC, H2TE, and highest value will be H2O. And for the ammonia thing, it's something like this, no? This is SbH3. It's the highest one. Then ammonia. Then ASH3. Lowest value will be therefore pH3. Like that, you can add others to your review. Ionic character of these compounds: lithium fluoride, bromide, and iodide. Ascending order of ionic character. So here the cation is same, anion is changing. No? Anion size increases in this way. You can say as the size increases, polarizability increases. Therefore, covalent nature increases, ionic nature decreases. If the ionic nature decreases, yeah, they're asking the ionic character. That you have to stop there. Ionic nature decreases. You can tell the same thing using electronegativity also. Fluorine is the one with the highest electronegativity, and largest difference will be there between lithium and fluoride. So it is going to be the highest ionic character. So the correct order will be the most ionic: lithium iodide, lithium bromide, chloride, then fluoride. This is the correct order. Understood that one? Polarization power and polarizability. Polarization power and polarizability. Polarization power is same here. Only polarizability changes. Right. The last point is about electron energy. So it is given 4 quantum sets: 2, 1, 0, minus half, and 3, 2, minus 1, plus half, and 4, 0, 0, plus half. Then you have 3, 1, plus 1, and plus half. So these are the 4 electrons. And by analyzing the first 2 quantum numbers, identify their sub-energy level. Okay, so this one is 2p, this one is 3d, this one is 4s, and this is 3p. Okay, so then who explains, which theory explains about the ascending order of the energy? Energy ascending order is explained using Aufbau principle. Aufbau principle. It says first 1s, then 2s, 2p, 3s, 3p, then before 3d, 4s is filled, then 3d, like that it continues. Here this one was asked, 4s, 3d is there, and then you have 3p and 2p. So this is the proper order, ascending order. But don't write 2p in your answers, okay? You have to write what? You have to write the quantum set, put brackets and everything, put commas and everything, and write the proper order. Don't write 2p, okay? That means this one comes first, then you have this third one, fourth one, and then the 4s, and finally 3d. 3d is having a higher energy. So most of you tried this one, but some of you got wrong because of that 3D 4S mix up. Understood? So I have to try it like this. First identify the sub energy level, then think about the Aufbau principle, which tells you about the ascending order of the energy. So can be done, okay? Don't worry. So like that, we can finish the discussion regarding our first structured essay. Okay, Lamai. So now let's finish the discussion for today. Write a good review and bring the review when you are coming to your next theory class, okay? So this paper you must do well, nah? So now it is done. We got the marks and everything. Now, like I promised, we are doing the discussion now. After the discussion, I'll give you another paper, another shadow paper of the same type of questions are included, right? And try that and see how you are improved. Let's say you got 40 marks for that test, right? You have to increase that marks after the discussions and after repeating the theory. Then you can be happy about yourself. That means you are studying this. Okay, so this is how you want to be prepared for your A levels. Okay, you got a very good idea from our class, and let's keep it running and keep learning, keep doing questions, and repeat. Okay, right. So I'm going to finish the class for today. I'll add the recording also soon. Can go through this again. So good night, everyone. Study well. If you have further doubts, send them as a message. Okay. Goodbye.